Hello and welcome to another session of SMI Academy. In this session we will cover the monitoring of the data load process in SMI. So as anyone who is familiar with the SMI application would be aware, there is a regular job, a job that runs on a set schedule that is responsible for updating the reporting database in SMI. Of course, anytime you have a job like that, it needs to be monitored. There needs to be some visibility into, whether or not there are any issues with the process, the load times, that sort of thing. So in this session, we're going to cover the ways in which you can monitor that process, have a look, into it and see, whether or not it's working, and if there are issues, we're going to give you some techniques you can use to identify the root cause and hopefully fix it. Okay, so in the SMI reporting database, there are a handful of tables that are responsible for basically recording data about the data load process itself. The first one that I want to bring to your attention is the one that you see on your screen now. It's called the load monitor table. So it would be within your SMI reporting database for any data source. This is not specific to HP Service Manager. This would be for any data source. So if you, if you have more than one application in SMI, then you're going to need to look at the reporting database for each one. So in this case, we're looking at the reporting database for Service Manager, but it could be any application: Asset Manager, Project Portfolio Management, BMC Remedy, ServiceNow, whatever it is. This table is sort of the high-level view of the data load process and the status of all the various jobs. So for every table that you map from your source database or from your Service Manager application, an entity is created. So you can see I've got an entity for incidents, I've got one for interaction, for operator, problem, etc. So every table that's mapped gets its own individual entity. And then I can see some information about that entity. So for instance, if I'm looking at incident, I can see whether or not batch loading is turned on. In this case, it is. Batch loading is what gives SMI the ability to only load the records that have been added or updated since the last time the data load ran. So this is what allows for the incremental updates. So if batch loading is not turned on, this would be a 0. And it would be a full refresh of the table every time the data load runs. In this case, batch loading is turned on. Run ID, that's more of a system value that you don't really need to be too aware of. The next two columns are the source count and the target count. So this tells you that the last time the data load ran, SMI found 131 records in the source database, so in this case the Service Manager database. And in the SMI reporting database, it also found 131 records. So this is good. Obviously, most of the time you want these two numbers to line up. It's not always a bad thing if they aren't the same. So for instance, if you have a certain entity, maybe even incidents, where you periodically delete or clean up the data in the source application, but you don't want that data to be cleaned up in SMI as well. You still want it to be available for reporting. Well, in that case, you might see more records in the target than the source, because in the source, you've archived and removed older records, but they're still present in the reporting database so that you can, have visibility into those records in your reports. So not necessarily a bad thing if these two numbers aren't lined up, but you have to understand whether or not that's normal in the case of that entity. So not always bad, but possibly bad. The next two columns here just indicate the date on which these source counts were taken. So again, obviously this was the data load was run on June 11th, 2014 at about 1:45 p.m. Server time. So we see that these two counts were taken almost at the same time, so that's good. If we scroll over to the right, we'll see some additional columns here. These four columns, found error computation, found error before load, found error after load, these indicate whether or not there was any issue during the last data load with this entity. So a 0 is negative or false, and a 1 is positive or true. So in this case, we can see that for this entity, for the incident entity, there was no error in the data load itself. There was an error in the computation, and then there were no errors before or after the load. And then the last one, filtered null keys indicator, that is basically an indicator that says whether or not it found records in the source database where the field that is the primary key, or that the application indicates as the primary key, is null. So again, not really a problem with SMI. This is more of an informational column. So if it did have to filter out records with null keys, then it will say so here. And if it did, then that's probably either normal for the application, depending on the source application, or potentially an issue with the source data. But that's what all of these columns indicate here in this table. So again, this is high level. You've got one row per entity, and you can see all of that information there at a glance in one table. Now, if you want to look at a more sort of a line-by-line detail of the data load process itself, then we would go into a different table called the log table. So the log table doesn't show us at a glance what the status of each entity is, but basically this is a running log that is generated and updated as the data load runs. So we can just tell by looking at this, what steps the data load process took. At a high level, you probably won't need to look at this data on a regular basis. Really, what's in the load monitor, and actually you won't even necessarily need to look at this table on a regular basis, because after the next thing I'm going to show you is how to get this information in an actual report rather than having to come to the database to get it. So as I was saying, this table is basically a running log of what the data load is doing. Usually you only need to go into this information when you're troubleshooting an error that you found at this level. So you can see it basically tells you what it's doing, when it started doing whatever's being described here, and it also tells you which entity the log line is related to. So you can see these are all related to configuration item. These are CI relation, then interaction, SLO response, etc., etc. So again, not something you would look at on a regular basis, only when you have to analyze a potential issue. The next table I want to show you is actually just an example of a table that exists for every entity. So if you recall, if we go back to this table, we've got all these various entities that are part of our job. And then for every entity listed here, there is a table called _batch _ the name of the entity itself. Let me undo that. And then _set. So that's the name of the table. And you can see on the left here, they're all listed. So, I've got incident set, incident or INC activity set, department set, category set, etc. If batch loading is not enabled, you will not have this table. So you won't have the set table if this value is a 0. So if you're looking for a table and you can't find it, make sure that batch loading is enabled for that entity. That would be the first thing I would check. But what you'll see in this table is the information for every batch of records that have been loaded. So you'll see here, we're looking at the batch information for incident, and every time it loads a batch, it writes an entry here. So you can see that this first batch with the ID number 1, the from date and the until date indicate the values for sysmod time that are captured here. So I should take a moment to explain that when you set up batch loading, one of the things you have to indicate is what the date field is that it indicates the last time a record was modified. So in Service Manager, it's almost always a column called sysmod time. In other applications, it could be a different column, but it always has to be a date field that indicates the last time the record was updated, not when it was created or anything else, but the last time it was updated. If that does not exist, then batch loading is not possible. So what this is indicating is that this first batch is capturing everything with the sysmod time between these two dates. 5/10, so May 10th, 2012 at 12:44, and May 10th, 2012 at 3:42 p.m. So within those two, at the time that this ran, it started on September 11th, 2013, was when this batch started loading. This batch finished loading about 3 minutes later, or actually no, 3 seconds later, or no, more than 3 seconds. But you can see that the difference here, it's 7:20 and 17 seconds, 7:20, 26 seconds. So this is when it started, this is when it finished loading the data for that batch, okay? Now the number of records that were in that batch is indicated here in the batch size. So it found 9,999 records with a sysmod time between these two dates. Now that batch size is also something that is specified in SMI. So in fact, let me open up REM here quickly, or Data Designer, and let me go into the data selection for incidents. So I'm opening up the data selection, and if I look at the Properties tab, you'll see these values. So batch loading is true. The default batch size is 10,000 records, so that's why when you look at this column, most of them have a number in the neighborhood of 10,000. Some may be a little different, but most of them are in the neighborhood of 10,000. Basically, we're saying 10,000 is the maximum batch size. Now, it could go over 10,000 depending on the data found in the sysmod time. So if you've got 9,999 records, each with a unique sysmod time, and then you've got 3 with the exact same sysmod time, again within that range, then the batch size would be 10,002. So it's a ballpark. It's not going to be exact every time. It's not always going to hit 10,000. Of course, when it's doing a data load, it also could be the case that there's less than 10,000 records have been updated since the last time the batch load ran, or the number of records that have been updated does not divide evenly by 10,000, so there's going to be some spillover into a final batch with a lower number, like you would see right here, this 5,716, something like that. So ballpark 10,000. 10,000 is the default, and it rarely needs to be adjusted. The only time I would recommend changing the default batch size is if you're getting a lot of timeout errors during your data load. So basically, the database server is not responding in a timely fashion and it's causing an issue. Okay, so the other two things, or the other two values here are I'm going to skip this for now and go down to the sync date field. So this is the date field that's being used for the batch loading. So as I said, in Service Manager, it's almost always sysmod time. In other applications, it could be a different date field. And then the default last sync date basically indicates when or what the default last sync date should be. And the last sync date is what SMI uses to determine how current the data is in the SMI database. So when you first set it up, before any data is loaded, it says the last sync date is January 1st, 1900. So what that means is when it first runs, it's going to add every record to SMI that has a sysmod time greater than this date. Of course, they will all be greater than this date, so it's going to load all the data. But what happens is after that first data load, in the SMI database, this last sync date gets updated to whatever the most recent value is in the sysmod time at the end of that data load. So the next time the data load runs, it's only going to look for records again with a sysmod time greater than the last sync date. So that's how it does the batch loading. So this is the default. So basically all you're indicating is here is, when you first generate the SMI database, this is the last sync date. It never gets used again after that. After the initial generation, this value is no longer has any effect on the solution or the application. Okay, so again, that explains what the from and the until dates are. The start batch date, the stop batch date is just the time that the batch actually ran. Start batch computation date and stop batch computation date, these indicate when the computation job ran. So the time that started and stopped. So if you have any data selection rules, that means that there is a computation job. So after the initial data loads are finished, so after it does the actual data load for all of the entities, it goes back and does the computation jobs, and that's what these start and stop dates indicate. And then of course we've got the batch size, the load result, a couple more columns here. These are more or less columns used by the system. Rarely do you need to really analyze those. The main things I wanted to bring to your attention here are these: the from date, the until date, the start and stop, the batch computation start and stop, and the batch size. Also, the state column indicates what's been completed. So a state of 0 means nothing has been done. A state of 1 indicates that a data load is in progress. A state of 2 means that the data load is complete. A state of 3 means that the computation is in progress, and a state of 4 means that the computation is complete. So when you're looking at tables associated with entities that have data selection rules, a 4 means that the data load or that batch was completely loaded successfully. If there are no data selection rules in that entity, so if there's nothing here, then a 2 in this column indicates that it's complete. But again, you're rarely going to have to look at this in any detail because there are reports that are part of SMI called health check reports that basically use this data and display it in a much more user-friendly fashion. So in your business objects environment, whether it's 3 or 4, this is 4, you'll have these health check reports, and there are 2 of them. You'll need a set of health check reports for every application that is part of SMI. So if you only have 1 application, you only need 1 set of health check reports. If you have 2, you'll need 2 sets, so on and so forth. So the 2 reports use the data that we just saw and allow you to easily determine whether or not there's issues with the data load. So the first one is just the health check report itself. This is the health check report. So it has several tabs. The very first tab is the differences overview tab. So since my demo system here, since all of the entities are aligned between the source and the target, meaning that there are the same number of records in the source and the target for all entities, this table is empty. If it did find any differences, if it did find any where the source and the target were different, they would be listed here, and it would use color coding to indicate if there were fewer records in the source database or more records in the source database. So orange would mean that there's more in the target. Purple would mean that there's more in the source. The next tab we have here is the record count comparison per entity. So in this case, we see every entity regardless of whether or not there's a difference. We can still see if there's a difference. That's what this column is here. And we still get the color coding if there is a difference. And you'll see that this is most of the same colors we saw in the load monitor table, same columns, I mean. So you've got the entity name. Is batch loading turned on? Was there an error in the data load? Was there an error with the computation? Were there records with null keys? And then here's the counts and the most recent record date based on the sysmod time in this case. So here, instead of looking at 1s and 0s, we actually see yes and no. And so if I look at incident, if you recall that incident had an error in the computed field job or in the computation job. So here we get a yes in this column telling us, yes, there is an error. So we might need to look into that. On the next tab, I can get the batch load information. So this is those. This is coming from those set tables that I just showed you. But rather than showing all of the records, it's only showing the ones that happened in the last 24 hours. So the table itself is historical. It shows everything. It never deletes any information. So if you haven't truncated those tables or cleared them out, you can go back to the beginning of when you started using SMI and see all the batch information. This report is only showing you those batches that were ran in the last 24 hours. So in this case, in my environment, 1 batch per entity ran in the last 24 hours. And we can get that same information we saw in the table. So when did the batch start? When did the batch stop? And then it also tells us what the duration was. That's not in the database. It's calculating that in the report. We also have the computation start and stop dates here. And again, we can see how many records had null keys, that sort of thing. And then that state column that I just explained to you in the set tables, where it's just a number in the table, 0, 1, 2, 3, or 4. In the report, it's actually, converting that or translating that into, English, so you can easily see what the status of that batch is. So in this case, load and computation completed, which would be equivalent to a 4. It's colored green, so obviously green usually indicates that everything is okay. So here we can see that there's no issues with these batches. Now there's, this report has multiple pages, so I can go on to the next page, and there's configuration item, contacts department, and look, there's incident. So remember, incident is the one that had the issue. And so here, it's saying performing computations, and it's orange. So if a data load were in process when I ran this report, then this would not necessarily be an issue because the data load is still running. But I know that no data load is running right now, so the fact that this is not green is a concern. And of course, I already knew there was an issue because on the second tab, I saw a yes in this column. So when I come here, I'm not surprised that there's an issue here. So orange, performing calculations, tells me that the status is 3. So it was performing calculations when it encountered the error, and so it did not move it on to a state of 4, which would be this green load and computation completed. So this tells me that there's an issue with this batch. Something's wrong with the records that are inside this batch, and I can look into that further if necessary. So that's everything there. That's everything you get with the health check report itself. Now that I know that there's something wrong with incident, now I can drill into that further by using the second report, which is the SMI data load log by entity report. This report does not run for the whole data load. So when you refresh this report, there's no prompts, there's nothing to provide. If you run it, it's just going to refresh the data. That's it. The second report, this one allows you to specify a specific entity. So I'm not going to look at all of the data. I'm only going to look at the data for a specific entity. So in this case, I want to see the information for incident. And that's what I've done. And just so you can see how that works, if I refresh, I can indicate what entity I'm interested in, and you can see here's the list of all the available entities. You can also enter the value for the log ID. Every time the data load runs, this log ID gets incremented. So in this demo environment, I've only run one data load, so log ID is 1. Now when I refresh this, if there were more than one data load, I would see more values in this list. So usually you want to get the last data load. If the last data load ran okay and had no errors, then that is a good indicator that there's no issues at all. Even if previous data loads had errors, if the current one doesn't have any errors, then that indicates that those errors were corrected, unless, of course, you manually intervened to basically, get around the error. But if there was no manual intervention, then an error in a previous data load that you do not see in the last data load or the current data load has self-corrected. And that does happen because sometimes you get errors because of infrastructure issues, connectivity between the application server and the database server, things like that. So if there's a connectivity issue, if there was a connectivity issue yesterday, then I might see errors in yesterday's load, but they self-corrected, or some other person corrected the connectivity issue, and so in a subsequent data load, it's self-corrected and everything is okay. So it is possible for things to self-correct or seemingly self-correct. And also, it does not, when that happens, or if a job fails, and then it tries that job again, the next time the data load runs, and it works the next time the data load runs, it catches up. So it's not like the data that was supposed to be loaded during the failed job gets lost. The data load is set up so that it always picks up where it left off, whether it was successful or not. So if a batch failed yesterday and then it tries it again today and it's able to do it, then it will load that batch before it moves on to future batches. So it does not skip over the data that did not get loaded. It will always make sure that all the data is loaded. So with that in mind, you typically want to look at the most recent log ID. You really are. It's very rare that you're going to want to look at an older one. So whatever values are listed in this list, you should always choose the largest value, the greatest value. So in this case, we want to see the details for the incident entity and for log ID 1, because that's the only one there is. So I would click OK. It refreshes the report. And now I get that information, and I can see here on the very first tab, which shows me only errors, that there was an error. It occurred at this date and time, and this is the information associated with the error. It's telling me that the message that it received was that string or binary data would be truncated. I can look deeper into this by going into the complete log for the data load. So this is basically just showing me the errors. In this case, there's only one. This tab shows me everything, and I can see each individual line from the log table for this entity. And if I scroll through it, of course, there's more than one page, and typically the error is going to be at the end, because it's going to stop once it gets the error. So there you go. If I go to the last page, here's the error. And then there's a few more after it where it's just saying that it exited the procedure and then went on with the job. But the actual computation job was stopped when it hit this error. So now I can see, looking here, again, there's the error message. And when I look at some of these other things like the SP name, I can see exactly where the issue is. So by looking at the SP name, I can see SP is for stored procedure. I can see that it's HP service incident computation load 1. This is what's really of interest to me here, because I can take this information and go back to Data Designer or REM and see what is in computation load 1. Going to REM, we're already in the incidence data selection, and under data selection rules, you can see I have 2 rules, and if you look at the procedure name, you can see which one is causing the error. So this is computation load 2. This did not have an issue. This is computation load 1. This did. So now I know that there's something in this stored procedure or in this SQL here that's causing the issue. And so now I know this is where I need to troubleshoot and figure out what's going on. In the case of a computation, this is really the best, or the most detail you can get. If it couldn't load the record itself, if it was an issue loading just the record and not doing the computation, then there are some stored procedures that we can use to look at that further. So what you would do, now you need access to the database itself. So if I were to go into my reporting database, I know I have an issue with incidents. So I'm going to go into programmability and then stored procedures. And here I'm going to look for the stored procedures for the incident entity. So you can see it's there's some prefixes here and then the entity name. So, and obviously this is alphabetized. So I'm going to go down to incident. So I can see from here to here are all of my stored procedures that load the incident data. At the end, you'll see a handful of stored procedures with the word trace, and you'll see that for all of them. So here it is for incident activities, And if I go down, to interactions, here they are for interactions. So if it was an issue loading data from Service Manager, from the source application, and you needed to know, well, which record is causing the issue, which record is it getting stuck on, this stored procedure would tell you. If you were looking at this report and you found an error in this column, load error, you could use these stored procedures. So if this said yes, then what I would do is I would go into my application server, I would find these stored procedures, and based on the detail, I would figure out whether it was an issue with the main incident data load or one of the jobs for these 3 specific fields. So the reason they're separate jobs here is because these are large text fields, so they get their own job to prevent any issues or to minimize the likelihood of issues. So what I can do is just run the appropriate trace procedure, and if you don't know which one, you can of course run them all, and you can run it in SQL Server Management Studio by right-clicking and choosing Execute Stored Procedure. And in this case, it's going to start running. In this case, it's not really going to find anything because there's nothing wrong. But ultimately, what you would get from this stored procedure is the ID of the incident record that's causing the problem. And then you could, that really narrows it down for you, and it would make it easy to troubleshoot. I know that I've worked with customers in the past where, you get an error in your data load, and you know that there's a specific record or records that are causing it, but you don't know what that is. Or you don't know which record is causing it, I should say. So the addition of these stored procedures is definitely definitely simplifies the process of troubleshooting. And as you can see now, since I have no issues with the data load, I get this message saying that no batch is currently in a running state, unable to trace down errors. Well, I expect that because there are no errors to trace down. So if there were errors, I would actually get some information here about what records are causing the issue. So I would recommend, if you need visibility into your data loads and you want to be able to monitor them and know when there's been an error before it starts impacting your reports, then I would definitely, in your environment, find this report, the SMI health check report, and schedule it. Put it on the scheduler to run, maybe once a day or twice a day if you run your data loads more than once a day. Schedule it, have it emailed to the SMI administrator or some other people who are responsible for managing the application, and so they easily would have visibility as to whether there are any issues that need to be addressed in the data load itself. So really, you would you get the report in your inbox. You would open it up. You would go to the record count comparison tab and look for any yeses in these columns: load error, computed field error. If you find any, then you got something to look into. So that's how you can monitor the data loads and troubleshoot any issues found within the data loads. I hope everyone found this webinar to be useful, and I look forward to speaking with you in the future and possibly in future SMI Academy webinars. So thank you very much. Goodbye.